All right, so today is going to be about review because we have an exam on Friday. I want to remind you that it starts 5 minutes early and ends 5 minutes late. So you'll have 70 minutes here if you to work on it if you're here at 5 till. Okay? So I recommend you take advantage of that. Today is, so I'll start off by asking questions. Anybody have anything they want to ask questions on? I will not answer specific questions on the extra credit assignment. Although if you want to show it to me and say, hey, am I showing the work the way you want? I will say yes to that. Not right here, but I'm going to be walking around at some point. But I will work problems like those on the extra credit assignment. Anybody have questions? Yes, Tiffany. Yeah, sure. I'd love to do that. Okay, so dimensional analysis problems. Let's go over one that's like on the quiz. All right, so on the quiz, we started off and we had, this one was actually broken out into pieces. But before we even talk about the actual question, let's talk about just in general. So far for dimensional analysis, we've done density, right? You could do other things as well, but one of the major things that we need to be able to do in this class is do these sorts of problems with chemistry concepts. And so you're going to need to be able to go from grams to moles, okay, and to molecules, or it could be atoms. And so if you have one of these, you can get to the other ones using either the periodic table or using Avogadro's constant. Remember, I will give you all constants on a test, and I'll give you the formulas you need on a test plus some more, okay? So if we're going from molecules to moles, we're going to use the conversion constant that 1 mole is equal to 6.02214 times 10 to the 23rd things, where things are molecules or atoms, but it could be anything. It's a counting unit. And then if I want to go between grams and moles, I'm going to use the molecular mass of the compound. Okay, or we'll say or atomic mass, or atomic weight. All right, so those are the conversion factors I need. I like to call this the moles highway. You have to get onto the moles highway to get to where you're going. Okay, these will become more complex as we go on. So this could be, I could give you up to a 2-step problem, right? You'd have to convert and then convert again to get to here. But as we go on, these will be more than 2-step problems. So you want to be adept at doing the dimensional analysis, which is why we have that extra credit worksheet, because it's super important. All right, so let's say we are on, let's do a problem starting it like it's on the quiz. The quiz started, it said, what is the molecular mass of, I keep trying to think of relatively small molecules I haven't given you before. Let's go ethane. Okay. Ethane has the formula of C2H6. Bless you. All right, what's the molecular mass of ethane? Go ahead and spend a minute at least setting that up. Okay, so we're doing molecular mass. It's going to be the sum of the atomic weights in the element. All right, so what I'm going to do is I've got 2 carbons. So it's going to be the 2 times carbon plus 6 times hydrogen. So for the atomic weights. So 2 times, I'm going to look at the number under carbon on the periodic table. Carbon's number 6. 2 times 12.011 is on this periodic table. Plus, for hydrogen, it's going to be 1.009 in this periodic table. So 6 times 1.0794. Everybody's got a different periodic table, right? On the test, you all have the same periodic table because I'm going to give you another one with the test. It's not going to be special, but certainly if you're working problems like on the worksheets or things and you don't, if you get exactly the right answer, like back here in these digits, it's a little bit different, or the significant figures are a little different based on your periodic table, don't worry, don't sweat it, okay? But so then I'm just going to put these into my calculator. And once again, I've talked about being adept with your calculator so you can do things fast. So I want to be able to do things so I don't have to write down each thing, right? I don't have to 2 times 12 and write it down, and 6 times 1 point blah and write it down. So I'm going to do it all together. And some of your calculators will just straight out do all of this. I got 30.0696. Let's see, 30.06, well, 070, we'll say. Is that what other people got? Closely? Okay. And so that's grams. The units on this are grams per mole. All right. Make sure you always put your units on there. This is correct significant figures because I've got 3 past the decimal point here, and I've got 3 past the decimal point here. Why didn't I make it 1 significant figure? Because of the 2. It's a counting number. It's exact, right? Infinite significant figures. It won't reduce my significant figures. Okay. I want to point out that there's another way of writing this. I could write that as 30.070 grams, and I should talk about what it is, of ethane equals 1 mole of ethane. I'm being specific with what it is here. That's not really going to be important with the level of problem you've got on this test, but later we'll be doing conversions between different types of molecules, so you want to definitely label what's what. We're not there yet. But I can write that as that. Let me get that all back on the screen. And that'll help me think about it when I use it as a conversion factor. Questions on anything I've done so far? Okay. All right. So then on the quiz, I believe the next question either had me go from grams to moles or moles to grams. I think it was grams to moles. So how many moles of ethane do I have if I have, let's say, 145.0 grams of ethane? Go ahead and take a minute and try to at least set that up. And you should be good enough at this that you can set that up in a minute. All right, I'm going to be a little repetitive here, but what I want to remind you of is whenever we have one of these moles to grams or grams to moles or moles to molecules or whatever, grams to molecules, which you should be able to do, but is remember we've got grams, right? I can go to grams to moles to molecules, let's say. What's my conversion factor that gets me back and forth between moles and grams? The formula weight, molecular mass. I don't know why I put a 77 there when I was using my pen, but okay. Molecular mass is under the 77 there or on top of it. And if I want to go from moles to molecules, what do I use there?
Avogadro's number.
Avogadro's number, right. Avogadro's number. That's horrible, but number. I'll spell Avogadro correctly on the test. Okay, but that's how I get back and forth. Those are my conversion factors, all right? So what's my given in this problem? What am I going to start with? Yes, exactly. I've got 145.0 grams. I'm going to just write of ethane. You don't have to do that yet. Okay, so 145 grams of ethane. What is my conversion factor? I'm going from grams to moles, right? What's my conversion factor? It's molar mass, right? Which we calculated right here. So I've got that little equal sign. What's going to go on the top and what's going to go on the bottom? Molar mass. So what? No, we're not going to use Avogadro's number here. But yes. Right. So we're going to go 1 mole of ethane. So I'm writing here, but I'm looking up here as I do it. 1 mole of ethane equals, I'm going to draw the little equal sign, okay, across that line there, and that's equal to 30.070 grams, that's a 0, grams of ethane. All right, so then I'm going to just put that in my calculator. I multiply everything on the top and I divide by everything on the bottom. I can do it all one step on my calculator to move fast. 1450.0 divided by 30.070. And what I get out of that is 4, it's putting it in scientific notation on me. No, it's not. Okay, sorry. I appreciate it. Thank you. 4.22 moles of ethane. Got it? Okay. And that's correct significant figures because how many significant figures are here? 5. 1, 2, 3, 4, 5. Okay. Didn't need to write that 0, but I did, so it's significant. How many here? 4. 1, 2, 3, 4. 4 there. Questions on what I did? Yes?
I have probably a stupid question.
You do not.
How
It's
do
a
you
great
know
question.
when to do scientific notation and when to just round?
You don't need to do scientific notation unless I ask you to. Okay? So I'll ask you to put something in scientific notation, or I'll use scientific notation in the problem. Okay? Other questions? All right. The next question on the quiz went from moles to molecules or molecules to moles, right? So let's see. It went how many moles, let's see, yes, of ethane do I have if I have 3.467 times 10 to the 25th molecules of ethane. Go ahead and work that. And if you're not sure how to start, remember this. It's a little bit of a mess up here. I apologize for the writing. But take a look at that. You'll get used to my writing over the semester. It's like listening to somebody with a deep accent for a long time. Okay, hopefully at this point you've all set it up. When I'm working it here on the board, I really want you, so this was a scientific notation problem, right? So we're going to use your EE key on your calculator. I really want you to punch the numbers in while we work it if you haven't punched the numbers in yet. All right, let's make sure that we're using the EE key correctly. I want to clear out any of the common mistakes that happen with it. All right, so we have, where do we start with this problem?
3.467 times 10 to the 10 to the 25th.
Right, exactly. We start with the number of molecules. So we've got 3.467 times 10 to the 25th molecules of ethane. All right, and what's my conversion factor going to be? So I don't have it written here in range of where you can see it, right? So maybe you just wrote Avogadro's number, AN or something, because you probably don't have it memorized yet. Maybe you do. But that tells me that 1 mole is equal to 6.2214 times 10 to the 23rd things. In this case, it's going to be molecules. Somebody other than Jack, I appreciate it, but somebody other than Jack, what goes on top and what goes on bottom for that conversion factor? Just tell me what goes on top. Moles, right, moles. Moles goes on top because I want these molecules to cancel. So just like I should have done up here to emphasize it, grams of ethane cancels with grams of ethane, and all I'm left with up here is moles of ethane, which ended up being the units in my answer, right? So down here, we need those units to cancel again, so we're going to put 1 mole ethane on top, and on the bottom, we're going to put 6.02214 times 10 to the 23rd molecules of ethane. And then molecules are on the top, molecules on the bottom. I'm left with moles of ethane. My problem asked for moles of ethane, so that's great. That's what I wanted. And that's going to give me have to put it. There's actually a lot of moles of ethane. It's going to be like 50, something close to 50. 3.467. I'm going to hit my EE key. Please do this with me. I haven't used this calculator before. See, this is an example of why you need to practice this on your calculator so that it goes quick on the test, right? If you haven't really looked at your calculator, you're going to have my response up here. Where's the EE key? And very quickly here, I'm going to give up and, oh, there it is. Okay. Found it. All right, so 25th, E25th, divided by 6.02214 EE23. All right, and so my answer is going to be down here, is going to be, well, it's 57 moles, actually. So it's not going to need scientific notation because it's one of those numbers. It doesn't need to be in scientific notation because I didn't ask. How many significant figures should my answer have? 4, because that molecules has 4 in it, right? So 57.57 moles of ethane. Okay, questions? That was exactly our quiz, except different molecules, different numbers, right? We'll change the numbers around a little bit. Okay, what about doing this in 2 steps? So since we're here, before I take more questions, let's do a 2-step problem. All right, so my problem's going to be actually it's going to be a 3rd step. So because you're going to have to get molecular mass for it as well. So how many molecules of, all right, another small simple molecule. Let's do NO. NO is this signaling molecule in your body. It's really simple. It's just a nitrogen and an oxygen. We haven't talked about polar and nonpolar, but it's small, it's nonpolar, and so it goes right through membranes. So it's this great molecule for your body for a short-range signaler. It was molecule of the year way back in like 1990 or 1992. You guys remember that? It's cover science? No? Okay. But how many molecules of nitrogen monoxide okay, so that's NO, just say no. How many molecules of nitrogen monoxide are in 356 grams? All right, so remember, we have our system here is that we've got grams goes to moles, goes to molecules, okay? And that our conversion factor here is molecular mass. And our conversion factor here is going to be Avogadro's number. 1 mole is equal to 6.02214 times 10 to the 23rd things. Okay? So I'm going to give you 3 minutes to try and set that up. Or do it. Doing it would be great. Feel free to call me over if you, I may be able to walk around the room just to be less bored. But call me over if you have questions about where you are, you want me to look at anything. Get finished early and you have a device with you, the odd number problems in the back of your book have their answers. So you could start working something else as long as you're here. Yes.
That would be grams per mole. That's grams per mole, and you can also think about it as grams equals 1 mole. And that's how you're going to use it as a conversion factor.
So is that what would be it?
Right? So grams is your 356 grams. That's how many you're given.
And the
This is your conversion factor you're going to use to get from grams to moles. Write out grams equals 1 mole. So I asked you to write out grams equals 1 mole. I want you to think about it like a conversion factor, not like a thing. That's all.
since it wouldn't be like this on these.
So-
356,
so- This is where you start. This is what is given to you. You have that many grams. Take a problem. And then, let's see what we got there. Yeah, that's it. Now put the units there. Grams, that many grams equals that many moles, because that way you know where to cancel. Yes, absolutely. That is what that's going to do. Absolutely.
Okay, let's go ahead and work this one. So I'm going to start with what?
356 grams.
356 grams. It's what's given in the problem, right? So you're going to calculate the molar mass, but I've seen some people trying to start with the molar mass. We use the molar mass as a conversion factor, okay? So I start with 356 grams of NO. And then I've seen other people do the conversion factor. So for time, if you do the molecular mass, you should have gotten 30.01 grams, okay, of NO is equal to 1 mole, right? So that's what people got for their molar mass there. Then let's go ahead and cancel grams. I know I put the right thing on the bottom and the right thing on the top because I can cancel grams of NO with grams of NO. Okay? So I need to be able to cancel, and that tells me what goes on top and what goes on the bottom. So then we need to go, so right now we're in, what are our units right now? If we just said equals on our calculator and we were done. Moles. And the way we know it is because that's all that's left for units, okay? But this is asking for molecules, so I need to go from moles to molecules now. What's my conversion factor for that? Avogadro's number, right, which I gave you right here. This is Avogadro's number, all right? So what's going to go on the bottom there and what's going to go on the top?
Moles is gonna go on the bottom, and Avogadro's gonna go
Right, moles is going to go on the bottom, and if I'm really being careful, I'll say moles of NO, but 1 mole of NO goes on the bottom, so it cancels, which means Avogadro's number goes on the top, 6.02214 times 10 to the 23rd molecules of NO. All right? And then if I look at this, I have moles of NO on the top and moles of NO on the bottom. My only unit left is molecules of NO. And so now I can put that in my calculator. I've got 356 times 1, which I won't bother to put in my calculator, but you could if you wanted, times 6.02214 molecules, or times 10 to the 23rd, okay, E23, divided by 30.01. And I've got 7.14 times 10 to the 24. Let me look at it for rounding real quick. Yeah, 7.14 times 10 to the 24 molecules of NO. Because that's my only unit left there. Is that what other people got? Okay. All right, all four of those problems. I'm writing the test right now, okay? All four of those problems, you'll see those sorts of problems on the test, okay? No question. So you need to know how to do that. Good practice would be to work that worksheet that's the extra credit worksheet and also get you all your points back on your quiz, all right? So go ahead and work that, set things up. Use the whole point of that worksheet is for you to work it and set things up and cancel the units. I've given you the answers, right? I don't care what you get for an answer. You care what you get for an answer, know whether you set it up correctly. I care about that you have this stuff set up on that worksheet and you cancel your units because it's a super important process. Okay, you had a question over here?
Yeah, can we go over like 1s and then 2s and other?
Yeah, let's do that. So what is the electronic configuration, or the electron, is it electron configuration of, let's do silicon. Okay, I'll give you the symbol. I don't expect you to memorize these symbols. And I'll probably give you a periodic table that has the symbols on them, or has the names written on them as well. So how are we going to do this? This is a 1s2, 2s2, etc. or thing. Okay, we do it electron configuration. And so I'm going to use the periodic table. Okay, we talked about, hey, here's the order these things are in. Here's how you, for the energy levels here, diagram, here's how you fill them in. But I'm just, and you can use those tools I showed you in the previous lecture, but I just use the periodic table of this. So I'm going to do this in my head. You would have to look up and down, right? I'm going to do it all here while I'm standing here, and I'm going to go over and write it down. But top row, 1s, 2, right? It's full. We're working our way down until we get to silicon. 2s2, 2p6, 1, 2, 3, 4, 5, 6. 3s2, 3p1, 2. Okay? Easy as that. That's why the periodic table is in the format it is. So we could say we're using it for cheating, but what it really is it's using the periodic table for what it's for. Okay? So 1s2, 2s2, 2p6, 3s2. And then I go look up at my periodic table or look down at my periodic table and I get to the 3p's. For silicon, I count 1 aluminum, then silicon over 3p2. See, I can use the periodic table, just burn those out, get those out really fast. Okay. Let's do another one.
Can we leave it like that, even though 3P's not half full?
You leave it like that because so that's good. So half full is good, right? But you can't make this half full, right? You only have, so full orbitals are special stable, right? So that's good. And if this diagram right here, so if I ask you for an energy diagram, you're going to have to unpair the electrons and then pair the electrons. We'll do one of those, okay? But this diagram doesn't show which orbitals are in, right? 3p, the p has how many orbitals? It has 3 orbitals, right? How many electrons go in each?
2.
2. That's where we get our 6 from. Okay? So 2 electrons per orbital, any orbital. All right? The p has 3 orbitals. That's why we have 6 in that p block over there when we look at it. But we can't see here how they're divided. This notation doesn't tell us how they're divided amongst the orbitals. So we don't need to worry about half full or partially full or anything here. We might use it later, but I don't want to spend too much time on that. Okay, so let's do one that uses the D block. Okay, let's go ahead and do bromine. What is the electron configuration of bromine? So in this case, Br. You may use noble gas configuration. All right, let's have you guys do this one. You don't have to use noble gas configuration. I'll give you a minute. Then I'll do it. It'll be a lot shorter if you use noble gas configuration. Okay. What I'm going to do then is I'm going to use noble gas configuration. What I do is I look at the noble gas, I take bromine and I go back. I'll go over and point at the board after I write this down, but I'm going to go back to the closest, the last noble gas before bromine, essentially. So that's argon when I look at that. So I put argon in brackets, and what that means is bromine has the electronic configuration of argon plus the rest of the stuff I'm about to write. All right, so it's a shortcut. If I look here and I take bromine right here and I work my way back to there, argon's the last noble gas we saw. All right, so everything's full up to argon plus 1, 2, 3, 4, right? 4s2. Now you need to remember here, this is a tricky part, you have to remember that the D's lag one number, okay? And if you want to remember that, draw the diagram. I'll show you the diagram in a minute that you can use to remember, help you remember that. But D's lag one number, so this is a 3D. 4s2, 3D, I go all the way across the D's are full, so 3D10. 4p, 1, 2, 3, 4, 5. So 4s2, right? 3d10, 4p5 is what we just did over on the periodic table there. Does that make sense? What we've done there? Let's ask another question here. How many electrons would a bromine gain or lose to make a stable ion? So what's our rule for this? Everybody wants to be a noble gas, right? Okay, if we were to personify our elements, everybody wants to be a noble gas. What's the closest noble gas to bromine? Bromine's 35. Krypton. Kr. You can just say Kr. It's krypton. Okay? So how many electrons do I need to gain or lose to have the same number of electrons if I'm bromine? To have the same number of electrons as krypton? 1. I have to gain or lose? Gain 1. Okay? Questions? Okay, yes.
Why is it like when it's like an element minus, you're gaining electron, but when it's an element plus, you lose?
So why is it when it's an element you,
So it's like,
oh, right, why, so this would make us bromine minus, is that what you're asking?
Yeah.
Okay, so electrons have a negative charge. Right, and protons have a positive charge. So neutral bromine has, if we think about number of protons and number of electrons, neutral bromine has how many protons? 35. Yep, has 35. Right off the periodic table, it's the atomic number. How many electrons would it have if it's neutral? 35. So 35 pluses plus 35 minuses, right? Okay. And then ionic bromine, okay, is going to be 35 electrons. We said to be stable, it would gain 1 electron, right? So it would have 36 electrons. And so you could think about it like this. I have 35 pluses plus, so this is one of those plus minus things, plus 35 or 36 minuses. And that's going to be equal to minus 1. Okay, and you could put it, if the plus minus thing confuses you, I think you could put it in your calculator just like that. Let me see if my calculator does it with the plus minus key. If I do 35 plus 36 minus, nope, doesn't work. Okay, this works for exponents. But I'm doing plus minuses. You can also think about just always subtract the electrons from the protons. Yes?
If calcium wanted to get like a minus from potassium, would I still go to potassium, or would you go all the way to?
Good question. Okay, so if it's not always 1 electron that's gained or lost, so if calcium was going to make a stable ion, everybody wants to be a noble gas. So it's got to get to a noble gas. What's the closest noble gas to calcium? If I want to go this way to calcium, I have to gain 10 electrons plus another 6 electrons, right? 16. Or I could lose how many? I could lose 1 for potassium, but I'm not a noble gas yet. If I lose 1 more, so lose 2, now I'm argon. Okay, so calcium would lose 2, and what would its charge be? Plus 2. Right. Okay. So we'll just write down the result there here. So calcium loses 2 electrons to become a stable ion. And if we want to look at that, what we'd be thinking about then is we're going to think about calcium as an ion, calcium ion, and how many protons does it have? 20. And it always has 20, right? It's not calcium if it has something else. So it's never going to change how many protons it has. And then my electrons, we said it lost 2, right? So we have 18. And so just use this for your formula. So charge is going to be equal to number of protons minus number of electrons, and it'll just be fine. Okay? So what the charge is going to be is it's going to be 20 minus 18, or that's going to be equal to plus 2. So my calcium ion then I would write as calcium 2 plus, like that. Questions on that? All right, let's do the energy level diagram then. All right? can't remember what they call this in your book, but draw an electron energy level and I'll like, to make sure we've got the right term, you're thinking of the right thing, I'll give like a little hint or maybe draw a little bit of it or something. Yes? Question or?
No.
Okay. Electron energy level diagram for, oh, let's see. Let's do something fun. Let's do, now let's just do cobalt, or I guess, let's, yeah. Sorry, let's do titanium. For titanium. Okay. And you may use noble gas configuration. So we're going to use our noble gas as a shortcut. What I want to do is I want to remind you of this little thing to help us remember what order these orbitals come in, or in terms of energy. So I've got 1s, I have 2s, I have 2p, I have 3s, I have 3p, I have 3d, I have 4s, I have 4p, I have 4d, I have 4f, I have 5s, I have 5p, I have 5d, I have 5f, and I'll put more in if we need them, but 5f. There'd be a 5g, but you never get to those g's. There's not enough elements to get there, so we never have to worry about g's. So 1s, then I do my 2s, then I do my 2p, then I do my 3s, then I do my 3p, then I do my 4s. So this is how I know that my 3d comes after my 4s. Then I'm going to do my 3d, then my 4p, then my 5s. We're doing titanium, so we're in that first D block, so I don't need any more orbitals than that. Okay? What's the closest, what's the last noble gas we see before we get to titanium? Argon. So we're going to do argon. So in terms of drawing this, I'm going to draw, and so this we do in a vertical way. I'm going to do argon plus, when we look at this, so argon plus, we're in the 4s, right? And then I'm going to need some 3ds. And I know I do 3d, 4s before 3ds because of the diagram I just did. You see that? All right, so how many orbitals in 4s? One orbital, 2 electrons, right? So I could draw it like this. I could draw the 4s under it, whatever I want to do. Then I'm going to do 3ds, right? 3d, how many orbitals in the ds? 10. 10 electrons, 5 orbitals, right? So remember this, we have for s, p, d, f, we're going to talk about number of orbitals, okay? 1, 3, 5, 7. It falls out of the quantum numbers, but so we're going to do 3d, I need 5 orbitals there, right? And then I'm just going to use the periodic table again, all right? 1, 2, right, in the lowest, and then I go 2 into, so I get calcium, potassium, and calcium, 1, 2, I'll walk over there anyway. 1, 2, fill those S's, 3, 4. Well, not 3, 4, 1, 2 again for the D's. And so the important thing here is that electrons don't like to be in the same orbitals if they don't have to. If you fill them all the way up, there's something special legal about that. But, so 1, 2, make sure I split them up. So that's what that one would look like. Okay? Yes.
Where goes up with this?
Yes. These are definitely fair game for the test, and I think I'm going to almost guarantee you they'll be on it. All right, we have a whole 8 minutes left. I'm not going to let you go early. Are there any other questions on things? Yeah.
Can you do another energy level diagram?
Like this one?
Yeah.
Okay, great. So let's go ahead and do an energy level diagram for, let's do phosphorus. Actually, better yet, let's do oxygen. Do an energy level diagram for oxygen. You may not use noble gas configuration. They must be taking a test next door because there hasn't been any music. And I'll give you 2-ish, 3-ish minutes to set that up. We'll see how people are doing, and then we'll fix it. Call you over if you have questions.
Sure, which one? I would just draw that diagram. The electrons, yeah, so the lower electrons are electrons, and you're going to fill them from lowest number to the highest number. You see the 1s of the first row. Yes, but you're going to want to do a diagram that you fill up, start at the bottom of your page, because it's got to go up. How high this page represents how high the energy is for the levels. So what I did, I loaded these vertically. This is more energy than that. So you need to do that. That's part of it. So I would, yes, I would 1s, let's do the first one, 1s. And I draw, okay, draw a line for the orbital next to it. At once. They don't, which side of the lens more orbitals, cross that one out first, okay? And then up here, then you put 2s, which is higher energy. One orbital, and then you fill with 2 electrons, and now 2p yes.
So you want to look at something in question?
Yes. Yeah, so accordingly, so don't have times, it's not it's just trying to just thanks for asking about that. That's a common mistake.
All right, let's go ahead and do this one. Let me do this one. So I can't use noble gas configuration, so I'm going to go across the periodic table. I'm going to start with 1s, 1s. I don't put the 2 in yet. I'm going to put 2 electrons in, 1 for hydrogen, 1 for helium, 2s. I'm going to put 2 electrons in, 1 for lithium and 1 for beryllium, okay, just to where they are in the periodic table. Then I'm going to go 3p, the P has 3 orbitals, 1 orbital, 3 orbitals, 5 orbitals, 7 orbitals. And so then I'm going to work my way across. We're at oxygen, right? So boron, carbon, nitrogen, and I have to pair one now, oxygen. And that's my electron configuration, and my electron energy diagram for oxygen. Okay, hopefully you guys got that. I'm available today 1 to 5 p.m. So if you wanted to come visit me for an appointment, come tell me at the end of class here, or send me an email before 1 o'clock. So I'm happy to talk to people then. And then we have a help session on Thursday at, yours is at 7:30, okay, on Google Meet. And the link for that is on my syllabus, which you can find the electronic copy online. Okay?
Why is it 3P instead of 2P?
It is 2P. Thank you. That is a fantastic question. Thank you for asking that. Yes, it's 2P.